Alright, hey guys, continuing the series with part 4 of the basic parts. We're going to call this one angle cuts because it's, I think, the first one with any cuts, extruded cuts that are at an angle. So we're going to talk about a few things with that and just bust it out just like the other ones. So on this drawing, nothing really specific, but you're going to see an angle and you're going to see a distance. Because, you know, Sakatoa, you're going to have that angle and one of the distances to complete the rest of the math of the triangle. So just be thinking about your basic math and geometry when you're looking at these details. You have to have at least a couple of these pieces to complete the whole. So if you're looking at it like that and you think there's maybe not enough information, the drawer should have given you enough, so make sure to put in their dimensions and see if it completes. So we're going to get started on this part. It's pretty easy. Let's start a new part because I do have it open in the other window. Alright, this is in millimeters. Let's look back at that part real quick just to know what we're doing. Oh, I hate it when it does this. I don't understand why it does this, honestly. Okay, so we have our part front, top, right, isometric. There's a couple different ways to draw this one. You could draw it here, put the angle in your original drawing, and then extrude it out, cut down, cut across. That works. That's like 2 cuts. You could draw from the top and then extrude upwards and then make the 2 angle cuts. And I think we're going to do it that way, mainly because it'll give us more practice with the angle cuts. And for the first time, we're going to be drawing on the top and extruding upwards. Something I didn't put in here, which I probably should. Let's throw the note here. We'll choose the origin is there. Cool. All right, now we know everything we need, I think, and I guess we could throw a material in here. Let's say carbon steel. Cool. Carbon steel. If you're hearing some crunching, that's my dog tearing up a toy, so sorry about the noise. One sec. All right, sorry about that. Let's continue. All right, so we have our origin, we have our material. Let's go back to our part. Sketching on the top plane like we talked about. And we know our origin was at that bottom left corner, so we'll start up and I believe crossed. It's like a sideways C. Oh, that's not right. We can fix that later. It's actually good we did that because we can talk about making things horizontal and parallel to things. So with our relations, we can control click and click that, and then we can make those parallel, which is cool. I don't often like to make things parallel because then if you do start making other changes somewhere along the line, that parallel might bug you. So I would control Z that. That works in SoildWorks, control Z in some situations. So be ready for that. You can just click on this and we can just tell it to go vertical. That works much easier, I think. All right, let's look at these dimensions. 75 tall, 100 across, 50 wide. Okay, let's put this one in and this one in because we're going to extrude up 50 and 100. But that's not what we need. We're calling this 50. We're calling this 100. Let's drag this over a little bit here. We have to put these distances in to make sure everything was right, and I believe it was 25 and 25. We'll put those in and then we'll go double check it. Like I mentioned in a previous video, it's often better to throw in your dimensions that you think you remember, because you can always just go in and change them real quick once you confirm at the drawing. And then if you were right the first time, you saved yourself switching over to double check what you already knew. Because on an exam, those seconds can take time. 25. Now we move right on, right? Now we're going to bring, we need this measurement in because we saw that blue line didn't go black there. So let's bring 30 in. I keep alt-tabbing, but that doesn't work. Sorry. Let's take this from here, and I believe it said 30. That doesn't feel right. I think it was the other way. Let's double check. Yeah, it didn't feel right. So we know the math. We can just do 20 instead of changing the distance from here to here. We can just do the math right. All right, let's extrude that. We're going to bring it up. I believe it was 75, we said. It might have been 100, but I think it was 75. 75 feels right. Yep. Okay, now we're going to make our angled cuts because we have basically this shape without this cut and this cut. It's pretty easy to make an angled cut. Sometimes you want to think about where your cut's coming from. Like on this one, we could sketch here and draw an angle across this open surface and then extrude cut that way. But I think it'd be better to rotate to the back view and sketch it here. Because then we could do this. Let's throw that in with no relations. We don't want any weirdness connecting. So those yellow lines, let's avoid those for now. And I believe it was from down here to here, and it was 30 degrees. Then there was a height of, I think, 37.5. Oh, that probably wasn't it then. Let's try this. Yes, that looks right. Let's double check. Yeah, good. And since we're drawing on the back, right, we cut across this plane as if we were on the back side of it, because if we cut on this side on the back side of it, it wouldn't come out right. Let's go back there and make our cut. So, and this is just, you know, what we've already been doing, but this time we're not making a circle or a square cut, and we'll do whole cuts soon. I don't think we've done one yet, so it's been square cuts mainly. But this is the angled cut. Same exact thing, it's just an angled sketch. And like we've talked about, there's a lot of different ways to make this cut. We could do, 50 and bring it right to that wall. We could do through all. We could do up to next. A lot of that would work. Up to next looks really good, honestly, to me, because it kind of, it also shows you that it's not going deeper into this structure, because we might end up drawing something in there. So let's make that cut. Cool. All right, last cut. It's a small one, but it's still there and it matters for mass properties. We got 15 in an angle of 45 degrees. And that's on this face here. So we could sketch on this face because, it's not going to jump off that line at all into open space on our sketch. It's all going to be sketched within that. So we can make a triangle. And I believe it was just 45 degrees. And we said this distance was 15. Okay, let's make that cut. Same thing. And it'll save our last choice normally, so that works. And I believe that's our shape. Let's go double check that ISO to confirm. This is always good practice when you finish a part. Double check that it looks right, because anything out of proportionality could really throw off your eyes. And once you see that proportionality, you'll know instantly. Cool. All right, I'm going to put the mass properties in the comments. We did forget to change this to carbon steel. Yeah, we'll just do carbon steel. Not steel sheet, plain carbon steel, because it's not a sheet technically. This isn't like an extruded piece. All right, and you can see it changed the color. Cool. And our origin point is still at bottom left corner. So I'll put that at the bottom of the comments. Build the part ahead of time, pause it at the drawing, build it, see how far you get. If you get stumped, play the video. When you finish up, double check all your dimensions. Go check the mass properties for the answers. Confirm you got the answers right. If you did, cool. If not, go double check again. And if you start to find that you have to keep double checking, that means you need to slow down when you're doing your sketches. And I was definitely a victim of that because I like to do things quickly. So I think that's it for this video. Appreciate it, guys. We will post part 5 here, part 4. I'm already forgetting. Like an hour or two. Thanks.